Hello everyone, in here we're going to explore this particular article here by NASA, which looks at these two galaxies here having some interesting behaviors and what these behaviors mean when it comes to how James Webb Telescope reveals the characteristics versus other previous telescopes imagery revealing their own characteristics, and how the merger of these two images gives us a wonderful look but a little bit scary look at this particular two galaxies here. So in here it says a blood soaked eyes, which is in this particular name for fun is called, and this here is going to be examining these two galaxy pairs. According to this article, it says that the one that is of focus is a smaller spiral galaxy, which is at the left, to be known as IC2163, and the one on the right here is known as what? The NGC2207, which is also a spiral galaxy. Now, in terms of the size of how they are, it says that this here is way bigger than that, and there is an interesting phenomenon that is making these two to interact with each other, which is the gravity that is at play here, how one is drawing the other towards itself, according to this article right here. And so when we look at this particular image, it says that this image here is a combination of the Webb and the Hubble's telescope images, and in terms of which parts are Webb and which parts are, I would say, Hubble, there are a couple of clues that can show you that for sure. Now, in terms of Hubble, it says that Hubble has a combination of two pictures here. One is known as visible light, alongside that of ultraviolet, according to what it says right here, and why the James Webb Telescope uses its mid-infrared light. And so in terms of the details, this here shows the galaxies, which is the IC galaxy and the NGC galaxy, in the mid-infrared from James Webb Telescope. And this here shows some interesting phenomena that we'll discuss in details in terms of those interesting colors and what they actually mean. Alongside, we're going to look at how James Webb Telescope shows or gives us a different take on it. So now, in terms of some interesting characteristics about these galaxies here, it says that each year the galaxies produce the equivalent of 24 new stars, and this year has pretty much sizes are kind of the size of the sun, our own sun. Now, in terms of our Milky Way, which produces around 2 or 3 new sun-like stars per year. So it's pretty incredible to see the rate at which this particular galaxy produces new stars compared to our own Milky Way galaxy. Now, it says that every supernova pretty much like places where they're like bursts of like stars, and in terms of explosion of stars, and this explosion of stars, we can actually have a lot of materials that are emitted out, and those materials here, we can see them in the form of gas and dust that later cooled, and these are shown by these colors that are a little bit white, I believe, in this particular image here. Now, when we look at other things in terms of what this article is stating, it states also in terms of, hey, the bright regions in the galaxies are mini star bursts that are locations where many stars form in quick successions. Additionally, the top and bottom eyelids of the smaller galaxy, and this here is filled with newer star formations and burns brightly, as we see right over here in terms of the upper and the lower eyelid regions of this smaller part. So it's pretty cool to see this particular comparison shown here, and here is the one that you guys have been waiting for with regards to the comparison between the Webb visible and UV spectrum image, which is pretty colorful and incredibly showing a lot of blue spots that are shown right here, and this blue spot signifies the emerging of new stars that are about to be born, and actually show that incredible high activity of star formation shown right there. And when we pull this curtain over to the other side, we see the Webb mid-infrared image right here. I must say, to be honest, I'm really more drawn towards the visible ultraviolet region here from the Hubble Space Telescope compared to that of the Webb. Webb is fun, but then when you combine this together, there are other things that you can see here based on this particular website features here. Another thing is having the toggle. This toggle shows you one side to be the Hubble, and when you click on it, it shows you the Webb image part. However, if you want two ups, you have those two side by side. So pretty cool to see this incredible features here for the view of these two galaxies. Now the other things, like in terms of the video about this particular galaxies, this is pretty cool. If you play this video, I mean, this is like from YouTube, so I've already watched it already. It gives you a really well detailed explanation on all the interesting characteristics of these particular two galaxies, how gravity of this bigger one here is pretty much drawing this smaller galaxy closer to itself, and at some point there will be some collapse that may happen, and it says it's predicted to be millions of years. I don't know how much in terms of order of magnitude, so it's pretty cool to see that event going to happen in the future. But for now, pretty interesting to see this phenomenon of how gravity plays a role in understanding how galaxies that are really close together interact with each other, most especially when you're considering the shape of those galaxies. For example, the spirals of those two galaxies, how they're slowly having a different form that is going to be taken as they come close together. So pretty cool stuff in here with regards to this particular article here. Now, in addition, according to this article, it says that if you want to spot where you have high activity of star formations in terms of looking at the two images, you can see that there's a high sequence look for the bright blue areas captured by the Hubble in the ultraviolet light, and pink and white regions detailed mainly by the Webb mid-infrared data. Now, larger areas of stars are known as superstar clusters. Look for examples of these in the top most spiral arms that were wrapped above the larger galaxy and points left. Now, both bright or other bright regions in the galaxies are many starbursts, locations where many stars form in quick succession. That is all I have to share with you with regards to this particular article from NASA, mainly combination of the James Webb Telescope with that of the Hubble Space Telescope view of these two galaxies coming together at some point in the future, and the process that is producing this incredible high activity of supernovas bursting. However, the result is causing the birth of new star formations, and as these two galaxies are coming closer together. Pretty cool phenomenon right here. All the same, thanks for following me through this. Truly appreciate it. Hit a comment down below and let me know your thoughts about this. By that way, we can talk to you soon. Stay smart as always and believe in yourselves.